Okay. Hi, everybody. Hi, everybody. Thanks for being here. Tonight we are going to dive into the world of data science here at Bending Spoons, and we are very happy as Data Science Milan community to have the chance to see what they are doing. And before delving into the presentation of Andrea Maiorana, we are going to see a little bit who we are. A lot of you already know exactly who we are, but I'm sorry for those people. And but we have a lot of new people here. Okay, so this is the topic of today, the data science meetup here. It will be followed also by a poster session, and this is a completely new thing for us. So let us know if you like the format, because we can do it again in the future. Okay, so we are an independent group of people passionate of data science. We are data science practitioners coming from different backgrounds, and we were born in February 2016, and as you can see, we have a sort of linear growth of participants, and today we welcome more than 100 people that decided to join us on the Meetup platform. So if you want to see every event that we organize, you can go and check on the Meetup page, because there you can see all the details of the events that are coming. Okay, so this is our staff. We are a lot of people, and okay, not the best for diversity, probably, but nevertheless. Okay, and feel free to get in touch with us if you want to contribute to the community. So if you want to have a talk in one of your companies, or if you want to have an independent talk, we can organize that. So we just need contributions from the community, because the strength of the community, of course, is the network, like we are doing today. Okay, and if you want, you can see a lot of previous events on our YouTube channel, which is Data Science Milan. And we also have a SlideShare account in which we try and upload almost every content that we share with the community during the events. And you can find us on different social networks. The first one is Medium, where we publish the general news about data science and about the events that are taking place here in Milan. And the other one is LinkedIn, where you find, obviously, all the updates from the community. An interesting, in my opinion, is the new format that we launched this year, which is a sort of, a digest, so a newsletter of news related to data science. So if you want to participate, if you want to check those contents, and if you want to write something, please feel free, again, to get in touch. Okay, and now we have a wallboard moment from our community. And today we have Merkel, which is a company that is hiring, and there are 2 open positions. The first one is for the head of business analytics and data strategy, and the second one is for the data scientist role. Both of them are remote, full-time, so if you want other information, contact us, or directly them following the links. And if you have any opportunities to share with the community, get in touch, because we can, of course, publish and get everyone know about these events. So, okay, once again, if you're interested in a talk, we can talk and we can organize for the community. And enjoy, and I will leave the floor to Eva for the company presentation. Thank you.
Well, I want to also welcome you all on behalf of Bending Spoons. We're very, very excited to have you all here. My name is Eva, and I'm going to be presenting a couple of words. Just one second. There we go. A couple of words about who we are here at Bending Spoons. Then I'm going to leave the floor afterwards for the hot topic of the day, which is a bit about data science and how we use it to help empower the Bending Spoons platform. But let's start with who we are. And considering that I'm now speaking to a group of data people, let's start with a couple of numbers. So we started as a little 5-person startup back in 2013. But we've grown quite a bit since then. Now we're 10 years old. We're one of the top up-and-coming European tech companies. We have over 400 spooners, as we like to call ourselves. We have an office here in Milan, as well, everyone in person can see. But we have an international culture, an international company overall. This means that we have really many people from different nationalities, so around 35 different nationalities working together, 25 different spoken languages, and many, many other information that could be interesting about our company. But of course, these are just numbers, and it doesn't tell us a bit about the driving force, because what pushes us to keep going forward, to keep reaching new heights? And that's our mission. So our mission is to create enduring positive impact on our users, on fellow spooners, and on society at large. And within the next couple of slides, I really hope to show you a little bit of actually how do we do that. So let's start with spooners. Well, for an ambitious mission like this, you really need a group of talented, driven people who believe in the same mission, who want to drive this mission with you. And in order to attract and actually retain this type of talent, we try to create the best workplace on earth. A bit ambitious again, I agree, but really we're hell-bent on creating this amazing workplace where it's gonna be the perfect place for people who are hardworking, who are driven, who are talented, who are team players, people who really want to reach amazing heights. This is the type of environment where they can thrive. Of course, we still have some way to get to becoming the best, probably, but we're quite proud of what we've achieved so far anyways. So we've won a bunch of awards, specifically for being one of the best places to work in Italy, but also one of the best places to work in the categories of millennials and women as well. So this is just a little thing that shows us that we're on the right path, but we're not stopping here. So we're planning to reach as high as we can go. Then I also want to talk a little bit about our products. This is indeed how we try to create enduring impact on our users. So we have a portfolio of products. Again, a couple of numbers. So far, we've had around 500 million total downloads of our products, most of which are our apps. We have around 140 million active users, so these are quite big numbers, and you'll see a bit more about all of this later in Andrea's presentation. And then we've received around 160 million in revenue in the previous year, and around, should be above 300 in this year, but wait for the official results to come out. And how do we actually try to improve the impact that we make? Well, one of the things we care about a lot is the quality of our products. We like to be sure that the products we give out there really provide value to the users who have them. And in order to do that, we take care of each part of the product development from the concept stage up until monetization, and we try to do it all in-house. So this really allows us to be the decision makers, to be the ones who drive the strategy and decide what we want to focus on. And the good thing is that since we don't have clients, we just have a portfolio of apps, it's really up to us to make the decisions on what we do and what we don't, with only one guiding factor, our users and the data we collect from them. Technology is, of course, a great tool that we use. You can ask many of us, one of the things that many of us do is to try to stay up to date with new developments within our specific fields. And we always try to see what's new out there, what exists, what can we leverage in order to build something new, in order to make our products bigger, faster, better in some way. And of course, considering all of this data that we collect, we really strive to make rational and data-driven decisions. Again, I think Andrea is going to be going a little bit more in depth on this, but this is really true across all of our teams, but especially when it comes to products where we really have kind of the most data to work with. And finally, it's not all about us. So in the beginning, when I was sharing our mission, I told you that we also want to create enduring positive impact on society at large. So we've seen that we've had success in many fields, and now we want to give back a little bit to the community. This is something I'm personally, especially, let's say, passionate about. It's something that I also do. And I can tell you that we've had quite a few initiatives, specific ones such as a sponsorship that we did in partnership with Employability, but also many other things where we try to find ways to really bridge the gap towards the world of technology for different underrepresented categories of people. And this is just one such example. I can tell you we have many, many more things planned that we're incredibly proud to share with the world in 2024. But as I said, this is not where it ends. We have quite a big road that we like to reach. Finally, I want to say thank you so much for the attention of this part. I'm going to give the floor very soon to Andrea. But since Leonardo asked for, sharing information about job opportunities and so on, I'm going to deliver as well. So if all of this presentation caught your attention a little bit, we got you a bit interested in bending spoons and a bit of how we work, then feel free to go to our jobs page. We have actually some openings for data professionals. You can take a look, or you can also come approach me or one of my colleagues later in the aperitivo, and we can chat more about it. Okay, so thanks you once more, and I hope you enjoy the event.
Hello, everyone. I'm Andrea, data scientist at Ben & Spoons. Today, I'm going to introduce you to some of the work that we do at Ben & Spoons in data science. I will do so by describing some of the projects we've been working on recently and also going in some details about some selected topics. Okay, so to understand the context and the motivation behind the work that we do, it's essential to get our company structure and business. So I will briefly touch upon it. So if we have to define what Ben & Spoons is in a sentence, we like to say that Ben & Spoons is a technology platform that builds, acquires, and operates digital technology companies and products. So we have a pretty unusual company structure, let's say, since we are not built to develop a specific product, but rather we like to think ourselves as a machine that builds, acquires, improves, and operates products, mostly digital products, across their whole life cycle. So our company structure reflects this idea of a platform. So we have a main central business unit that we call indeed the platform, that supports several product units with some general purpose operations such as HR, recruiting, finance, and so on, but also with the tools and technologies that are essential for their business. So these range from cybersecurity, infrastructure, but also tools for analytics, product experimentation, marketing automation, machine learning models, and so on. So in particular, we have several data scientists working in the platform. And so basically today I will focus on what the platform provides to the product units in terms of data science, knowledge, and services. I will do this by covering some of the topics that centers around computing complex metrics and serving them to the company. So we develop tools and best practices for the usage of these metrics. We develop predictive models for the KPIs we are interested in our product units. These are used in product experimentations, user acquisition, and more. Finally, we do research that supports our work that we do in the platform to develop technologies that support our user acquisition, engagement, and monetization, and so on. Before going into the details of these projects, I would like to give you a sneak peek of the main data pipeline of our Ben & Spoons platform. So I was starting from the left. So we collect a lot of data from our products that are mostly mobile apps. So we collect data from the clients and the backends of these apps. These are typically data about usage, user actions, but also app configurations. Then we retrieve data from the app stores. These are, for example, in-app purchases data, and but also like app store metrics. And finally, we retrieve data from the advertising networks on which we run our marketing campaigns to advertise our products. So basically, we collect all this data through a number of tools that we develop on purpose and that are managed by a number of platform teams. After the collection of the data, we have some ETLs processing this data for better usage, and these data are then stored in a centralized data warehouse, which is the single place where all the company can access this data based on their needs. So here is where data analysts, but also business intelligence tools, but also predictive pipelines read the data and make the most out of them for the day-to-day usage. So in this presentation, I'm going to focus on the bottom right corner, so how we use this data and we make compute metrics and make predictions with them. Okay, so the core of the work we do as a scientist is around the idea of measuring and predicting app user metrics. I will start by discussing how we tackle the problem of measurement in some specific cases. So as always, for analytics team, the first problem is to collect data from the products and build some key performance indicators that can support decision making out of them. So this is generally a task for data engineering, let's say, but in our business, there are important cases that require some research, even just to build some these KPIs that we can collect from the data. So the typical example of this is the computation of these average app user profiles. So like the one depicted there. So the idea here is that you take some user level metric and you measure it starting from a specific moment in the life of a user, typically the app install, and then you average these values over all the users belonging to a given user base. So this is a concept that every data analyst, product manager, or growth manager uses like every day in our business. So it's important like that we have a scalable way to compute this stuff and to provide it to everyone who needs it. So I'll briefly cover how we do this part. So the first step is, of course, figuring out how you compute these numbers. So more precisely here, there is a problem of estimation of some unknown profiles on some sample users. And so more precisely, the problem here is that we would like to build some non-parametric estimators for these profiles that are ideally unbiased and efficient. Moreover, we have to attach some confidence interval to these estimations because the main use case of these profiles is basically when you compare them across different user bases or user cohorts. So imagine, for example, when you do an A/B test, you would like to compute the profiles for different segments and tell whether they are different. So you need some confidence intervals to do this. So we need to do this estimation of the profiles and the confidence intervals. There are a couple of things that you need to take care of when you do this, when you try to solve this problem. So one is the problem of censoring. So typically, we want to compute a profile, but we don't have all the users observed until that point. So, but at the same time, we don't want to throw away all the users that were observed earlier because they contain precious information. So, for example, imagine that you want to compute some, I don't know, the day 30 point of a profile, and yeah, but most of your users were observed up to a previous day. So you have to figure out a way to include these users in the computation, but at the same time, I mean, of course, they cannot reach the final point. So there is some things to take care of. The other problem is that of correlations, because the different points of these profiles are typically strongly correlated with each other, which generates some issues when you want to compute confidence intervals. And if you don't take care of them properly, you might end up like doing gross underestimations of these intervals, which can lead to wrong decision making. Like, for example, you may like think that two segments in an A/B test are different, significantly different, but they aren't. Once you've taken care of these problems and you end up with some formulas like the ones written there, the next problem is writing down some code that computes these numbers. So it's not hard, of course, to come out with a Python script that makes the computation, of course. But if you do this, you immediately realize that there is a big problem. So given the computational complexity of these computations and the fact that we need to do them on a very large number of users, typically, I'm talking about like tens of millions of users, the problem is that your script doesn't scale at all and you can do these computations. So the idea we had to solve this problem is to leverage the computational power of Google BigQuery. So the idea is that we take these formulas and turn them into SQL code and then ask BigQuery to do the computations for us. This is, of course, requires some care. You end up with very long and complex queries, and also you need to be careful to how you write the queries, because with these numbers, with these sizes of users, and given the frequency at which we compute these metrics, I mean, costs are not a negligible factor. Next step, now that we have found out how to compute this stuff, we need to serve these computations to who needs them in the company. We need to do so by basically tackling 3 different problems. One is abstraction. So what I've said so far should apply to a multitude of cases. So we should do this computation for an arbitrary user base and for a wide variety of metrics. Let's make an example. So you might have one business unit that is interested in computing a metric such as, I don't know, what is the average number of times that a certain in-app action was done by users that installed in a certain period and made another action in another period. So these requests might be very specific and still worth answering. And so we need to find a way to make this possible without, of course, having to recompute the SQL query each time you want to make a slightly different request. Second, there is a problem of speed. We would like these requests to be formulated and answered as soon as possible. Yeah, so ideally, we would like this to be feasible in a matter of seconds. Here in the picture, you can see an example of how an analyst would make a request of, here, for example, it's a revenue profile computed for a couple of user bases, defined as user from Splice, which is one of our products, who installed in a given period and coming from 2 different countries. So just to give an example of how a high-level request would look like in a Python library. Second, there is a problem of accessibility. We would like to make these computations available to everyone in the company, also non-technical spooners. So the way we decided to tackle these problems, mostly speed and accessibility, is by developing an architecture like the one sketched in this picture. So the computations are done in the cloud by a tool that we develop on purpose. And this tool exposes some APIs so that when you want to make a metric request, you have to formulate it as a HTTP request. But this is helped by some client libraries written in high-level code, like the one that I showed you in the previous slide. And also we have some web UIs that can help you making the requests. So the idea here is that you can decide what is the metric that you want to compute. You formulate your request either through a client library or a web UI. The tool retrieves the data from the data warehouse, makes the computation, and gives you back the result, typically in the form of a plot like that, so a profile plot. Okay, so this is everything about these computations. Now the final part is, of course, to make these useful. So use it in the day-to-day decision making. Here, there is also some data science involved sometimes, because we can adopt some common techniques in analytics and statistics that are typically used to help decision making, such as variance reduction, statistical tests, and multi-arm bandits. And here, the problem for us is to adapt these techniques to the specific use case of profile estimation. Okay, I will move on to the next section. So I'm going to talk about how we predict user metrics. So the problem, if you only rely on measure metrics such as these profiles I've been talking about so far, is that you typically face a trade-off. Either you measure, either you take a quick decision, but you have to rely on a very short profile, or you wait longer to have a more accurate and longer measure of a profile, but you have to postpone your decision. So the way we try to escape this trade-off is to make predictions of how a profile or any other metric will look like in the future. We typically tackle the problem of prediction in two ways. Let's say we have two main categories of predictive models. On one side, we have single user predictions. So here we typically take a black box model and we attach some numerical value representing some metric to each single user. The second type of models is cohort level predictions. So typically we are interested in the average value of some metric across a user base, so not really on the single user prediction. And so another approach is instead of averaging single user predictions to directly aim at predicting the average. We have been doing so with a number of different techniques, but yeah, roughly the idea is that I mean, you start with an observed profile until a certain point, and you would like to predict how it will look like in the future. So basically, you need to find some meaningful way to extend it in the future. Let's see some more details about these two approaches, starting from the first one. So here, in the case of single user predictions, our main problem is to predict the lifetime value of each user. As a function of their attributes, such as the country they come from, their device type, and other, and the actions that they made until that point in which we make a prediction. So actions might be purchases and usage of a product. So if you try to tackle this problem naively, let's say, you can think about training a model based on this value that you want to predict on past users. But here you face two main problems. So first is that since we are interested in predicting long-term metrics, there is a problem if you train the model on old users, because those are very different from the ones you are trying to make a prediction. And so also because the products have changed a lot in the meanwhile. In fact, typically, often we don't even have a single user that can enter such a training set, for example, because one product is pretty new. So there is no way you can do this in this way. Another problem is that we would like these predictions to be always up to date based on the recent actions of the users. For example, imagine that you make a prediction and then the day after the user either does or does not the renewal of a subscription. Of course, that changes a lot your best guess of what's the lifetime value of the users, and we want to take this into account, of course. The way we solve these difficulties is by developing a pretty complex model architecture that involves taking several models interconnected in the sense that one is trained on the predictions of the other and so on. And we also had to do some research work to come out with the best way to build up a training set by taking users from different products and mixing them up in a particular way. If you want to understand more about this, if you are attending in presence, then I suggest you to speak with Elena in the poster session, as she is going to present a poster about this topic. So we have in production, we have a model based on these ideas, and that makes an updates to the prediction, makes an update to the prediction of each user of our apps, basically every day. And this is mostly used for paid user acquisition. So we want to solve typically two problems here. So one is to decide how much we can bid for ad space. So how much we can afford to pay for having one of our ads shown. And here the idea is that roughly we take the users that are similar to the ones that we are targeting and use the predicted values from this model. The other usage is about monitoring ongoing campaigns. So as soon as users are acquired, we estimate the long-term profitability of this campaign using these predictions. And this is very valuable because, of course, we cannot wait for years before understanding that one campaign is unprofitable and we have to close it. Okay, good. Let's switch to the second type of predictive models, so cohort level models. So as I said before, here the idea is roughly to prolong in the future some observed metric profile. We did so with a variety of approaches. So the simplest one was to take some models from the literature and try to adapt them to our specific use cases. So these models are typically parametric models in which the actions of a user are schematized in a simple way, like you have some events like the install, then you have another event like the starting a subscription with a certain probability, and then there is another probability that the user does the first payment and so on. So roughly you have these models where you have these probabilities as parameters, and you feed these parameters to the observed data. The interesting thing about these models is that they are fitted only on data generated by the specific users for which you are making a prediction, so not on other users. The cons of these models are, so first, they are pretty schematic and rigid, so it's hard to include some very specific features of our products in these models. So they contain a lot of information that we could exploit to make better predictions, but it's hard to include in this type of models. Second, since these models are not based on any prior knowledge, only on what is observed about these users and some very mild assumptions, they take quite a long to fit, and typically several weeks. And this is often too much for us, because we would like to make product iterations faster than that. So we needed to start developing some corrections and some heuristics, trying to include all the specifics of our products in these models, and we actually changed quite a lot the model overall. And yeah, we managed to find some approaches that led to better, more accurate and faster predictions. Currently, we have an ongoing effort to trying to replace all these models with a completely different approach, which is based on sequence deep learning models. And this is ongoing right now, and we also have a poster about this. So check it out with Fabio after the presentation if you're interested. Yeah, so basically the most interesting use case for these types of model is for A/B testing, since there typically you are A/B testing two versions of an app, like an old version against a new one. And if you use models such as the single user model that rely a lot on past data, then you may bias your predictions, because you have like trained the models only on the early version of the app, not on the one that you are trying to test. And so these models are probably better suited for this type of problem. Okay, so whatever the model we are talking about, whatever the assumptions behind it, the heuristic that we implemented in the model, the black magic under it, whatever, we have one issue, which is we would like to validate the model in a rigorous way. And the common problem we have in validating this type of models is that we train and validate the models on data referring to past users, while the main usage of the models in production is for users that have just started using your products. So there is quite an intrinsic problem with this, but at least we try to improve the quality of our validations with a couple of solutions. So one is a sort of tool that we call the time machine, that allows us to take let's say a picture of all of our users at a specific point of time in the past. So we basically ignore all the data generated by these users and any other user after that. So we train the models on these data, and then we validate the models on what happened after this cutoff. So both actions done by the same users after that and new users. Another approach that works to validate cohort level models, in which a single prediction is done for each user base, so is to build some collections of user base that we believe to be representative of the use cases that one typically finds in the real world usage. So we take some user bases from all of our products, and we collect them in a proper way. And so the idea here is that by taking measuring the average performance of the models on these user bases, we try to figure out what is the performance we can expect in production. Okay, now I will briefly mention a couple of applications of what I've discussed so far. So problems we are working on right now and that are more specific. So one refers to user acquisition. Here we have, in the platform, we have a team named User Acquisition Technology that manages marketing automations. So we automate all the advertising on search engines and social media. One of their main problems is understanding how much we should bid for ad space to maximize the returns, of course. There are some data scientists working on this problem, so there are some difficulties in doing this. So first, as always, we would like to optimize for the long term. So when we decide how much we can pay for an ad, the idea is that, we would like to pay an user based on what we expect that user to generate in terms of revenue in years. So to do this, as I mentioned before, the approach is using single user predictions and take all the predictions related to users that are relevant, so similar to the users we are trying to target, and roughly make some averages of these predictions. But this is not the end of the story, because you need to take care of other problems like competition in the advertising platforms, incrementality problems, and you would like to find an optimum trade-off between volumes. So if you increase your bids, you will get more users, but at the same time you will reduce the return on investment on the single user. So you need to find the optimum here. This is a problem that is basically unsolvable by first principle. You need to experiment. So we try to adjust the bids according to what we measure regarding the users that you acquire. So there is a lot of trials and errors here. Finally, there is a problem with user attribution. So of course, if you have to estimate the profitability of a marketing campaign, you need to understand which are the users that this marketing campaign acquired. But this is not always possible. So we need to, because when you acquire a user, typically it's hard to tell whether the user comes from a specific campaign or from maybe it's organic, we don't know. So we need to implement some heuristics and probabilistic models trying to figure out what are the users that we can attribute to a campaign. Another problem we are working on right now is that of product personalization. So here the idea is that we would like to personalize a product, so the experience that a user has in a product based on the user features and what their preferences ideally. This is something we're working on now. So the idea is that we try to maximize some KPI for different groups of users. The difficulties we are facing are mostly these. So first, if you want to make a very granular personalization, you face the problem of low statistics. So you have few users with specific features, and if you want to collect enough data to make accurate decisions on these users, you need to prolong your experiments and postpone the time at which you start exploiting the learnings. So yeah, there are quite a few trade-offs here. Second, again, we would like to optimize by long-term metrics, but typically, those are long-term, so you cannot wait for months or years until you measure such metrics before deciding how to tweak the parameters of your models. Finally, there is one operational issue here, which is that we would like to implement this personalization in products that are often in a stage of quick iterations and evolutions, and there are a lot of ongoing experimentation in these products. So this generates some conflicts with the personalizations we are trying to do. So this is also something to take into account when we develop these tools. This is a problem that we're working on now, and we have a poster also on this by Alessandro, so check it out if you want to know more about this. Right, so I would like to conclude by some summary remarks on the features of these problems and how they are related to the peculiarities of the business we work on. So, first of all, we deal with several business-to-consumer products. They have like millions of users. So in total, we currently have like 140 million monthly active users. This, of course, generates a lot of data, so something we are very happy about. So we have a lot of, we have a very nice playground to try a lot of different things, but also, there is also a challenge to identify what are the things that are worth doing and how we can extract some value from all this data. Second thing to take into account is that as I said at the beginning, we support multiple independent product units. So here, it's important to understand what are the common issues they have, and we have to implement solutions that are good for all of them, but at the same time that are also like very appropriate to their specific use cases and easy to use for every spooner, basically. Finally, there is another aspect that is specific of Benny Spoons, and also something that I find particularly exciting, that the company's priorities and focus change pretty quickly. So, these are based on the current state and success of each of the products that we manage, and it's pretty frequent that we reallocate the resources in the company based on the current needs, so where they are mostly needed. This makes it so that we frequently face new opportunities, so new problems, so stuff that we need to figure out, and these are completely changing, and yeah, we need frequently to switch to new problems. What is the optimal profile for data scientists to work in this specific context? So first of all, as we need to face frequently new problems, it's important to be able to quickly learn how to tackle them. So I would say that rather than being interested in a very strong vertical knowledge, we typically appreciate more solid foundational skills and very good common sense. So really to have the ability to quickly grasp new stuff. Second, we often find ourselves having to prototype and to figure out how to implement solutions to new problem again. And this requires like using a very diverse toolbox, and we need to validate ideas whether they can actually make an impact on the business. If not, we move on to different approaches or different ideas. Finally, there are also cases in which you actually we actually find it valuable to invest a lot of time and effort in diving deeper in some specific problems. So in this case, there is also some long research to do, so you need to be able to leverage some more complex techniques and a more structured approach to solving these problems. And this is it from me. So thanks for your attention. Now, before we move to the aperitif and the poster session, of course, we have some time for questions. Mm-hmm.
Microphone? Or?
Yeah.
Thanks. I'm curious about your company structure.
Mm-hmm.
So you described the hero data scientist profile. So if I understood correctly, this profile is part of the platform technology teams, no? So do you have data specialists of some kind also in product units? Are they autonomous to something, or what kind of profiles are, if any, in product units?
Yeah, we do have we do have a lot of data and AI roles also in product units. So that depends a lot on the context. I would say typically these are more, in the case of data roles, they are more like analytics roles. So it's more about applying all the stuff that I described to the specific business problems of the unit. But yeah, I mean, we also have a lot of people with a background and I mean, they do day-to-day analytics and stuff related to the analysis related to their products, yes.
Hi, thanks for the presentation. Are you using some or exploring some causal inference techniques to do the estimates for A/B testing, or interested in building some causal models?
Currently, not really, but it's something we are considering time to time. So we haven't yet figured out how it's best to prioritize this kind of research. But yeah, it's within our radars, let's say. So it's not something we have actively worked on so far. There is a product unit that they are autonomously trying to apply some techniques for their specific experiments. So yeah, but we haven't really try to make a company-wide effort about it yet.
So thank you very much for your talk. Another question regarding the company, I would say. So I strongly believe that there's no data science in a company without a widespread data culture around it. Are you trying as a data science team to widespread it across all the different professionals you have, or are you doing some specific activity to do this, or maybe there's already a strong foundation in data in Bending Spoons?
Yeah, I definitely agree with the comments. So this is more generally part of the mission of the data roles in general. So it's not really something that the data scientists in the platform deal with specifically, but this is something we really care about. So we have analytics in a variety of we use analytics in a variety of problems in the company. We also have an analytics unit in our recruiting team, for example. I mean, this is something we really care about, and we try to put some data person everywhere, and also not just that, but also trying to mentor everyone in any role to do the. I mean, not just, it's not really just about data, it's really about making decisions that are based on empirical evidence. So whatever the tool that you need for doing it is, typically it's analytics.
Thank you for the presentation. My question related to the ad optimization spending in general, because this is the most which we are interested in the university, or my research specifically. So considering that, for example, Google stopping the cookies maybe next year, or I think next year. So how do you rely on how are you, for example, relying more on using, instead of attribution probabilistic models, usually using marketing mix models, like the traditional way of understanding how you're spending, or which other channel are affecting the sales or the downloads or the user behavior the most? So is this the part of the problem you mentioned, because you mentioned it as one of the big challenges in your work? And also, since also he brought the causal inference, looking at the marketing mix model, that what I assume that most of the companies now will going towards after stopping relying on the cookies, for example. Is this a part of the strategy, like for the next year, for example, or are you doing this for the company itself when you start branding the company or doing online marketing or Google paid ads? Like, are you trying to understand using more statistical methods to understand which kind of spending affected most the effectiveness of the advertisement, of the downloads, for example?
So I'm not sure I get the second part. So are you asking whether we are planning to adopt some causal inference technique to the problem of attribution?
No, not causal inference in particular, like in general, using more traditional method for the next year or for the following years, instead of relying on the attribution models.
I wouldn't say we have specific plans about it because I mean it depends a lot on which networks we focus on at each time. So in the past, yeah, there has been a trend that makes it always harder to attribute the users that you acquired, and with time we gradually adopt techniques that allows us to overcome this problem. I cannot answer in detail also because it's very domain specific. I mean, every advertising network has its own problem, and you tackle them in a different way. But yeah, I mean, if you're interested in knowing more, you can talk with people working on this specific problem. They can also give you some more like hints about the specifics of how we manage the absence, the lack of ability of attribute users in some cases.
Thanks.
Hi, I have a question about the work that you do on the advertising platforms.
Mm-hmm.
So you mentioned that when you compete for like an ad spot on a website, you need models to predict the lifetime value of that user to decide how much to bid for that particular ad. But do you also try to optimize which product to advertise at any given point in time to maximize the return on investment for that ad, or are those predictions like product specific and those ad bidding decisions just product specific?
I would say the second. So we basically, yeah, it's hard that we consider like competition among our products. So like we're not that big to like being able to compete with. Maybe in some cases it happened, but I honestly I can't remember how this was tackled. But in general, no. We basically, if we decide, okay, we have to advertise this product, so let's see what is the value of the users that we believe we can acquire with this product, and then we compute a bid based on this estimate and other factors such as competition, but mostly with other companies, rather than with other products of us, and incrementality and other problems that inform the way you compute the bid at the end. So, but yeah, but maybe it's a good in something that in the future we might have to worry about more.
Thank you.
Okay.
Final questions? Okay.
Okay, good. Thanks for your attention. Then I suggest we move on to the aperitif and enjoy.